So in some ways this is obvious, and in some ways it's not, as are many topics. So this is protecting data at rest. And I'm really focused here on SaaS and PaaS services, not stuff you stand up yourself, although it applies there also, but really things that are hosted by others, that are run by others, infrastructure owned by others. So SaaS and PaaS, and the two areas that I've been working with lately, or for a while, is streaming services, streaming and messaging, and persistence, right? So we're going to talk about SaaS and PaaS, streaming and persistent services. And when we talk about protecting the data, what are we talking about? We're talking about data sitting somewhere in storage. And in this case, we're going to be talking about disk or messaging store. And the question is, what are the risks that we're trying to protect ourselves from? And I'm going to talk about why this is kind of important. You got to figure out what you are concerned about. And if it's hosted by somebody else, then a lot of times the things people focus on maybe is the vendor, what the vendor staff can do, right? Can somebody who's an admin on that environment, because it's a SaaS service, you don't know how it's managed, if they log into the box, can they see your data? And then another one would be vendor termination. Hey, we hosted with these folks and now we've terminated this and they've got our data sitting on their disk, and even though they claim they got rid of it, we don't know that, right? So how would we protect ourselves? Another one is disk reuse. You'll see this in two ways. One is the vendor cycled through some disks, or they unprovision something and reprovision it, and you reprovision it with a different disk. You'll see this if you do it yourself, like with a VM, right? That would be something you hosted, but in SaaS and PaaS services, they do exactly the same thing. And so disk reuse. The other attack there is the eBay attack, where somebody sells a drive, the disk shows up on eBay, and somebody mounts it up and they see your data. So then we have the other kinds of data things that we want to protect from. And the reason I covered those three up front is one of the most common refrain protects you from only one of those. And then we have unauthorized logins. That could be somebody on your system actually going after that data, somebody logging in, and we'll talk about that, and client machine compromise. That's a case which is really the kind of a big risk. There was some malware attack that I guess script or something, they got on the box, and either on the box itself or on the client in this case, and would they be able to see your data? There's privilege escalations. There's a normal process on the box and it got privilege escalated to a root permission. What I'm talking about here are techniques that would be immune to escalated account privileges, right? If we can do that. Control plane. So sometimes you'll have an admin console and people can view data or sample data from the control plane, and we would prefer that they not be able, even if they have permission, not be able to see any sensitive data. So we might be a little more subtle there in what we want to protect. We have cases where we want to let people join between data sources without seeing the data, without the data being available in any way, and then without the data being exportable. And so the question is, how would that work? And what I'm going to start off by saying is, if you look at the attacks there, drive encryption with vendor secrets is never enough. I personally feel, I'm sure I'll be told I'm wrong, but any security team that signs off on drive encryption with using the vendors, the provider's secrets as the primary protection for data at risk, I think is probably not have any idea what they're doing. Oh, and I overstated it, but I'm the king of overstating. So let's look at, the three probable main ways if we have a database that we could actually make this happen. The primary one you hear about all the time is drive encryption or disk encryption. I guess it's drive now because you're not on a disk anymore. In this case, what we do is we encrypt the file system. And what that means is, and then that file system is mounted up in with a decrypt fashion. The good news about that is it actually protects you from, it pretty much only protects you from the eBay attack. And I don't mean to knock eBay. I mean the reseller attack. And that's pretty much it, right? And the reason is that file system is mounted up in front of you, in front of that machine. Anybody logged onto that box, if that file system is mounted up, generally the way this is done, they can see that data. And so any escalated privilege where they get outside of a sandbox can see that data. So to my mind, disk encryption. Oh, and if they have used the vendor keys, then they can just move that disk to another machine and mount it up with their own keys, and they can see your data, even if it's deallocated and reallocated. So like I said, one way, if I was going to do disk encryption, which it should be required everywhere, the best way to do that is to use your own secrets that are shared and not rely on the vendor. And then, so none of that did payload, right? So on the disk, it still looks like it's unencrypted. That's what this is supposed to show here. We just have first name and last name and payment amount and an ID. The second way you can do that is field encryption. And a lot of times you'll do one or more of these. Actually, you'll always do disk encryption plus something else if you've got your act together there. So for field encryption, we just encrypt the sensitive fields. And the rest of that data is in the clear because it's not sensitive. And that works pretty well, right? So that if a vendor were to log in or you had an escalated privilege attack on that machine, they wouldn't be able to see the sensitive data, right? And then you generally have two ways of decrypting the path for execution. One is an auto encrypt decrypt, and the other is externalized encrypt decrypt. And the deal with those is a lot of times in databases, they'll auto encrypt decrypt for a field, and that can be good or bad. What it really means, though, is, again, if it means that if somebody gets access to the drive, they won't be able to read it, or even if it's mounted in that machine, they won't be able to read it by dumping the file system. But if they query through the API, the auto encrypt decrypt will automatically encrypt and decrypt that for you. So pretty much, unless you're highly disciplined, highly organized, and actually most systems don't support this, you'll just get the field back decrypted because it was encrypted on the file system and the disk was encrypted, but the API is not encrypted, right? And the other one, and so the other option there is to do externalized encrypt decrypt. You always get data in and out of this field encrypted system. The documents are always field encrypted, and then you make an external call for every field to decrypt those, right? And the other option in this is document encryption. And so in this case, we basically look, I'm going to use a document database again, I'm going to pretend. And in this case, we just encrypt the entire contents. And so the advantage of field encryption here is for non-sensitive data, we could still run queries pretty easily, right? Even if it was externally encrypted, decrypted, not internal to the store, you could say, show me all the ones with payment amounts over $300, right? If you do document encryption, basically this is sort of the brute force way. You'll see this in data lakes sometimes. But basically you just encrypt the entire record. And maybe you have the ID so you can retrieve by ID, but you got to make sure that the ID doesn't have any sensitive data in it. We actually worked with a vendor on this because basically anything that was a primary key or a primary key was always decrypted so that they could retrieve by primary key. In this case, the body of the rest of the thing would be encrypted. Now I've actually seen cases, anyway, so typically you'll run disk encryption and either document encryption or field encryption. Field encryption makes it the easiest to use because you can see all the non-sensitive fields. Document encryption, you know you're secure. Even if somebody were to log into the disk or mount it up somewhere else, even if they had your encryption key for the drive, it wouldn't help. They would actually need the encryption keys for the entire document. So the other thing I was going to point out is streaming. You see this a fair amount here. I've got Kinesis, Event Hub, and Kafka. And the same thing applies. If you have a third-party vendor, you want to know that your disk is encrypted. Remember, you want to use your keys, not theirs. That would protect you from them unmounting the disk and mounting it somewhere else. And then a lot of times, if you're messaging, the messaging contract will automatically tell you you need to encrypt fields. So you'll actually have a field encrypted item in the topic or queue on a disk that's encrypted. The other thing I've seen is sometimes it's just a lot of work to figure out which fields are sensitive. And so rather than do that, we just encrypt the entire payload. I'm going to encrypt the payload, send you a message. It's going to go down onto the disk drive on the messaging system, and then we'll be able to pick it back. Since those systems are usually first in, first out, there's no key problem, retrieval problem. We just need to know the key that's used for the partition or topic, and we're good to go. And so that's it. That's what I was going to point out. Basically, figure out how you want to protect your data at rest, and then decide which of the three most common or combination of encryption that you want to use. I hope that was useful. Have a great day.